partial derivatives. So what we have is we look before at functions in more than one variable. Say z equals f of x y to be, let's say, xy squared plus xy plus 3y squared. That's a function in two variables. If I'm asked to evaluate, or we say fix a value, let's say for y, say y is 2. So how does that work? X stays x, but y, we replace y with 2 and see what we get. 4x plus 2x, 4 times 3, 12. So the answer is 6x plus 12. So what happened here now, if I want to find the derivative of this function that I just obtained, it is only one variable. Only x is the variable here. Only x is variable. Since I fixed y as 2. So y is always 2, just for this specific example. So in this case, what we have a new notation here. To find the derivative for a function in two variables, we are going to differentiate with respect to one of the variables, either x or y. So that's called partial derivative. So partial derivative of the function f with respect to x. We can use this notation, partial of f with respect to x, like this. That's a new notation. Or you can write it partial z, because f is z with respect to x. This means the y would be considered as a constant. In this case, all other variables beside x are constants. So you deal with them as constants, as numbers. So if I want to write z, let's say x squared y plus 4xy plus 2y squared, and I want to find the partial of f with respect to x. So watch how we do this. I see a y there. Do you see it in the first term? So just write it down, because it's a constant. What's the derivative of x squared? 2x plus. I see another y. Keep it as is. What's the derivative of 4x? It's 4. Now look at the last one. There's no x's here. All these are variables, so the derivative for that one is 0. So the final answer would be simply 2xy plus 4y. Note, partial f partial x can also be written as fx, like this, f sub x, or f sub x xy. They all mean the same thing, the derivative of f with respect to the variable x. So for the same function, x squared y plus 4xy plus 2y squared, we are going to find partial f with respect to y, which is fy. How are we going to find that out? Well, in this case, I'm differentiating with respect to y, so we consider the other variables as constants. So here, this means x is a constant here. So partial f with respect to y, this is f of xy. With respect to y, let's see. X squared is a constant, just bring it down. Derivative of y is 1 plus keep the 4x the same, derivative of y is 1, plus the derivative of 2y squared is 4y. So that gives us x squared plus 4x plus 4y. So for this example, find f sub x and f sub y. So to find fx, we find the derivative of x squared, 2x, minus derivative of 5x is 5, and we keep the y. Derivative of y squared is 0. Derivative of 2xy is 2x. Derivative of x squared, 2x, plus 0. So let's see what we get. These cancel, so we get 2x minus 5y. That's the derivative with respect to x. With respect to y, derivative of x squared is 0 minus 5x plus derivative of y squared is 2y. Derivative of 2xy is 2x minus 0 plus 0. Negative 3x plus 2y. Can we have more than two variables? Yes, you can have more than two variables. Let's say u equals x squared y cubed z to the 4th. We want you to find partial of u with respect to x, partial of u with respect to y, partial of u with respect to z. Let's go over them. Partial of u with respect to x would be, the other things are considered constants, so we just find the derivative of x squared, which is 2x, and copy the other stuff down. Partial u with respect to y, you keep the x squared the same and the z to the 4th the same. Derivative of y cubed is 3y squared. Partial u with respect to z, keep x squared y cubed the same, and then 4z cubed. 4z cubed. So you can have as many variables as you want. Let f of xy be 7x cubed y squared minus xy. Find fx xy and fy xy. Okay, we can go over this one. So we need to find fx first. Partial derivative of this function with respect to x. We keep the 7y squared the same. We just find the derivative of x cubed, which is 3x squared, minus this one here. You can write it as 1yx, like 1 over yx, like that. So 1 over y stays the same, derivative of x is 1. So this becomes 21x squared y squared minus 1 over y. For the next one, fy xy, first thing I'm going to do, I'm going to write the function again here. But I'm going to rewrite it. Instead of having a fraction, I'm going to bring it up like so. Xy to the negative 1. So now this part, the 7x cubed, stays the same. That's a constant. Derivative of y squared is 2y. Minus, keep x the same. Derivative of y to the negative 1 is negative 1 y to the negative 2. We just have to simplify now. This is 14x cubed y plus x y to the negative 2. Don't leave negative exponents in final answers. So what do we have to do here? Keep this the same. Bring the y to the negative 2 down as y squared. another example for fxy equals e to the xy plus x natural log of y. Find fx and fy. Okay, so we can go over this. Fx first, the derivative of this with respect to x. If you recall two things, derivative of e to the u, it's u prime eu. And derivative of natural log of u, it's u prime over u. So for this one, I need to find the derivative of the exponent times itself, plus I'm finding derivative with respect to x, so the natural log of y is just a constant, keep it as is. Derivative of x is 1. So what's the derivative of this one with respect to x? Just the derivative of x, which is 1 times y is a constant. This stays the same, this stays the same. So that gives us y exy plus natural log of y. We need to do the same thing for f sub y. F sub y, the derivative of this plus x is a constant, derivative of natural log of y. So what does that give us? Derivative of xy times itself plus x times derivative of natural log of y based on the formula is the derivative of y 1 over itself. So what do we get here? When finding the derivative of xy with respect to y, x is a constant, derivative of y is 1, so this stays the same. This is x over y. How about if they ask us to find fy of 1, 1? Same problem, but fy 1, 1. In this case, whatever you found for fy, replace x with 1 and y with 1. Plus 1 over 1. So that would give us e plus 1. Just in case. Another one, fxy is given 8x natural log of xy. We need to find fx and fy. The difference between this one and the previous ones is that we have here, when we find fx, I see 8 is nothing, just a constant, but then there's a x and natural log, so there's two functions, so we have to use the product rule. So let's call this one function 8x. So we find the derivative of this with respect to x times the next one, plus keep the first one times the derivative of the second one. That gives us 8 natural log of xy plus keep 8x the same. Derivative of this is the derivative of u, means derivative of xy over itself. This stays the same. The x cancel each other. 8y over y, so the y cancel. So the final answer would be 8 natural log of xy plus 8. So let me write the fxy back again, 8x natural log of xy, and we need to find f sub y. So again, here differentiating with respect to y, so all this is constant, you just keep it as is. All we have to do is just find the derivative of this. So fy equals 8x. Derivative of this is the derivative of that one over itself. So what do we get here? The x cancel, 8. Derivative with respect to y is simply x over y. So the answer is 8x over y. 8x over y. One other example, let fxy 2x minus 7y plus 8 to the 5th power. Find fx and fy. To do that, for fx, keep the 3 as is. We bring, it's like using the formula u to the m. It's m times u to the m minus 1 times u prime by the chain rule. So you bring the 5 down, subtract 1 from the 5, becomes 4, times the derivative of the inside one with respect to x. So let's see what we get. 15. This stays the same, no need to change anything in this one. Times derivative of this one is simply 2. This is 0 and this is 0. So the final answer would be to multiply the 15 and 2, that gives us 30, and keep the other stuff the same. 7y plus 8 all to the 4th power. Let's go over the next part. Fy is again the same thing. You bring the 5 down, subtract 1 from the exponent, so it becomes 4 times the derivative of 2x minus 7y plus 8 with respect to y. So that's 15 here. This is 2x minus 7y plus 8 to the 4th times negative 7. Then we are going to multiply the 15 by negative 7, so that's 5, 3105, and this stays the same. That would be the answer. Now we have what we call it higher order partial derivatives. Which we'll be using in the next section. So if we have, let's say, z equals f of xy equals 4xy squared plus 3xy plus x squared, and we need to find partial z partial x, which is the same as partial f partial x. So we just find the derivative with respect to x. This is 4y squared plus 3y plus 2x. Now I can take this answer I just got, which is partial z partial x, and find its partial derivative with respect to y. Partial derivative with respect to y. So this means I'm gonna find the partial derivative of this answer I got with respect to y. And that would give me 8y plus 3 plus 0. Now this thing that I just wrote, partial y, partial f, or partial z with respect to x, you can write it as partial square of f, partial y, partial x. That's just a notation for that. Or some people write fxy. Now you have to pay attention to this notation. In this notation, if they ask you to find this, means you find this one first. So you find the derivative of f with respect to x, then this one, then you find the derivative of the answer obtained with respect to y. So again, this, I'm gonna write it here. This says you take the partial derivative with respect to x, and then with respect to y. So if you are asked this partial x partial y, you take with respect to y first, then with respect to x. How about if they have xx? So what you do, with respect to x first, then you take the obtained answer, do it again with respect to x. So with respect to x twice, 2 times. To see an example on this, 6x squared plus 3xy to the fourth minus y squared. Find just so you know, this one here, you can write it as fxx. This is fyx, and this is fxy. Just different notations. We're going to solve this example. See, how do we get it? So for the first one, we first find with respect to x. Remember, with respect to x. So what do we get? 12x plus derivative of x in the middle term is 1, so it's just 3y to the fourth, and the last one has no x's, so 0. Then this one would be taking the partial derivative of the answer with respect to y. That would be 12y cubed. Let me write the function again. 3x y to the fourth minus y to the second. We need to find partial f with respect to y first. The first one is 0. Next one would be 12xy cubed minus 2y. Then the second derivative with respect xy is basically we take what we got and find the derivative of this with respect to x. So first we do it for y, then x. For x, this would be just 12y cubed. For the next one, again, let me write down the function. 6x squared plus 3xy to the fourth minus y squared. We need to find fxx, let's say. So the way to do this, we first find fx, means the derivative with respect to x. That's 12x plus 3y to the fourth. Then we do it again. Fxx with respect to x is 12 plus 0. For the y, Fyy, how do you do that? We first find with respect to y. The first one is 0, the next one is 12xy cubed minus 2y. Then Fyy is 36xy squared minus 2.